Hey guys, in this video we are doing another example for graphing transformations of parent functions, and this example says p of x equals 2 times the quantity of x plus 4 squared minus 8. I just realized the other one had a 2, a 4, and an 8 too. I wasn't being too creative when I typed these. Sorry. Okay, so let's get going. So what is the parent function? The parent function for this example is x squared. Now what does x squared look like? You should know what x squared looks like. All the perfect squares, 0, 1, 4, 9, 16, 25. If you look at the distance between them, they're separated by consecutive odd increments. So if I square 0, I get 0. I'm going to erase this in a second. If I square 1 or negative 1, I get 1. If I square 2 or negative 2, which is going to be one further out, I'm going to get 4 for both of them, which is 3 more than 1. Then if I square 3, I get 9, which is going to be 5 more than where I just was. If I square 4, I get 16, which is 7 more than where I just was. So that right there is showing me the parent function for the parabola. Another thing we can look at right over here. Oh my, this is too big. Let's make this smaller for you guys. There you go. So over here we have another image of this parent function, and you can see, maybe if I have, where's my little pointer? Bam, there it is. So I can show you a little bit over here. From the vertex, wherever it is, you're going to go over 1, up 1. So the ups are in yellow and the overs are in pink. Over 1, up 3, over 1, up 5, over 1, up 7, over 1, up 9. And you should make a beautiful parabola. And then these dashed lines are really the crosshair of wherever your vertex is, which will be your HK, right? So if you have a vertical stretch, that means my yellow numbers are going to multiply by the vertical stretch. So in this case, we have a vertical stretch of 2 over there. So instead of going up 1, 3, 5, 7, 9, you're going to do double that. So 2, 6, 10, 14, 18, and so on. Obviously, they're kind of big. You're not going to see that many. If that was a 1/2 in front, you'd be 0.5, 1.5, 2.5, 3.5, 4.5, and so on. Okay? So that is what we got right there. Okay, so now let's list our transformations. So they are going to be, I'm going to say we have to go left 4 and down 8. Then we have the 2 out front, and I can abbreviate that VS, vertical stretch of, not 8, hello, vertical stretch of 2. Okay, so let's go ahead and put in our little crosshair where our graph is moving. So we got to go left 4, 1, 2, 3, 4, down 8, 2, 4, 6, 8. Okay, so I'm going to put a little crosshair representing my new origin. I really can't stress it enough. People sometimes put 2 points down, especially like x cubed and cube root, and then they accidentally think the other point that they put is the point of inflection and mess everything up. Draw the little plus sign, okay? Just trust me. I've been doing this since God's dog was a puppy, so I know better than you. Trust me. So there is my vertex of this parabola. There's no reflection, so the parabola is still going to be opening, classic, upward, both ends pointing up, and behavior up and up, right? So instead of over 1, up 1, we're going to go over 1, up 2. For the next step, instead of over 1 and up 3, we're going to go over 1 and up 2, 4, 6. Instead of over 1 and up 5, we're going to go over 1 and up 10. I don't know if that'll fit. 2, 4, 6, 8, 9. I mean, right there. And like that. Okay? So very carefully. If you turn, obviously this is an iPad, I'm not turning the paper around, but if you can take your hand and like turn your paper to make it a little bit more natural for you to draw whatever it is you're drawing, it should go smooth. It should be like good feeling that you're doing the right thing. And when you misplot something, you'll know, okay? I pointed out today, one person, if you are watching, like you had forgotten to move over, you did the other point above that. So think about it. When you were drawing that, did you know? Did you know it was wrong? You know what I'm saying? So chances are you probably know, okay? So what's the domain? All polynomials from left to right, they're going on and on forever, no interruptions. The domain is negative infinity to infinity. The range for even polynomials, for even poly, right? Your range is either negative infinity to a number, or it's a number until infinity. If it's positive, it's this one. And if it's negative, it's that one. What do I mean positive, negative? I mean the leading term. The leading term here is really 2x squared if you think about it. So it's going to look something like that second option. If it was an odd poly, this is poly, not PDY. If it's an odd poly, the range is negative infinity to infinity because its end behavior is down and up. So this one is going to be, though, bracket negative 8, the k, essentially. You know, comma, infinity. There you go. Max or mins? Well, there's a min. It's an absolute min. And that would be, we'll just say at, we're going to write the coordinate for now, at the point, -4, comma, -8. That's where you're going to find absolute min because there's nothing lower. There is no maxima going up toward infinity. You don't have a maxima. So that's the end of this video. I'll have a playlist pop up at the end of this video. That playlist is graphs with transformations. There's probably a ton of examples on there. I don't know if all of the, I didn't really look, if the thumbnails have the example on them. I try to usually do that. But if you need more practice, just pick an example from there, try it, and then check the video to see if you're right. Okay? This is the second video. More coming, 6 more after this. And the Quizzy will come soon. I promise. There won't be a big delay between the next video and this one uploading. It took me a minute for this one because this little, where is he? Gentleman behind me was needing to eat. All right, bye.